Now we are going to explore reinforcement learning and deep learning, and these are two advanced AI approaches that are pushing the boundaries of what is possible in healthcare. And this is through reinforcement learning and deep learning. And these represent the cutting edge of artificial intelligence applications in the medical setting. And as we discussed before, reinforcement learning learns by trial and error through feedback loops. And I gave you an example. And this image, you can realize an example right here in this image. One example could be optimizing ventilator settings, patient responses. Then you could have treatment optimization. You could look to optimize patient's diabetic regimen, their blood pressure regimen. Um, a lot of these things. You can look to optimize their medication dosing and your implications in robotic surgery. So now in robotics, this is huge. And this is how robots are learning. You know all about Tesla robots. They were very flimsy and couldn't hardly walk early on. And now they can walk and run. You can see all the robots coming out of China. You can see Boston Scientific. Initially, they were not that good, but they learned through deep learning and reinforcement learning. They learned that you have to stand up, you have to walk, you have to get up. So the same similar thing is happening in healthcare with robotics. How to suture, how to make this anastomosis, how to do this microsurgery without cutting a vessel, perhaps. So all of these are happening, and we're going to talk all about this in the program. Now, let me give you the sepsis example again. Now, in sepsis, the blood pressure is a big problem. So blood pressure would be low, and you want the blood pressure. You actually want the blood pressure to be, higher. Let's say, for example, the patient is getting vasopressors. So vasopressors are medication that increase a person's blood pressure. And people in healthcare, of course, will know about this. This is a no-brainer for them. So let's say, for example, the patient's blood pressure goes less than 90. This is a negative outcome. This will lead to increase in the dose of the vasopressor. This will lead to increase of the dose of the vasopressor, and hopefully the blood pressure may go up. And my friends, the AI system has saved the patient, and this happens every single day, every single ICU on earth, that a nurse is going back into the room, back and forth, that the blood pressure is going up, blood pressure is going down, and then when the blood pressure goes down, the nurse has to increase the amount, the rate of your medication, your vasopressor medication. And if this can be done relatively automatically, then it will save a lot of time and headache for the nurse, and possibly better outcomes for the patient, because it could happen the nurse is busy with some other patient and the blood pressure is dropping, but there is a need to adjust your vasopressor. Hey, increase that norepinephrine drip, increase the vasopressin, whatever you are using. And this could happen within seconds or even minutes, when the system has analyzed that, hey, yes, the blood pressure is going down, let's work on this, instead of giving out an alert that the nurse may not see for the next 10 minutes or somebody else may not see. And this will happen immediately, and patients' outcomes will be much better. Now, deep learning, my friends, deep learning is the holy grail. We talked about artificial intelligence as the big umbrella, then machine learning, and then deep learning. It's not deep that it's the deepest, and however, it is also very special. Now, this uses systems where there are neural networks with many layers of processing. Many variables are being looked at, many labels are being looked at, many computations are happening in very complex patterns. And this can result in processing and identifying increasingly sophisticated patterns. It can look at numerous variables that you may not look at. Specifically, let's say a junior doctor who does not have the skill right now, who does not have the insight that a senior physician has. A senior physician will just walk into the room and say, okay, this is happening, do this immediately right now. A junior doctor may have to look at the lab work, the labels, the vital signs, look at the medication list. A senior doctor will have been there, done that, and has understood what needs to be done immediately. And this is what deep learning can bring to the table almost immediately. Now, I have to point out that this image I got from Wikipedia, and this is the source. Now, neural networks, to recap, neural networks are many layers that mimic the brain function. They mimic your brain function. It's like a senior physician integrating multiple subtle cues. And this could include medical imaging, convolutional neural networks, uh, patient monitoring through recurrent neural networks, and of course, genomics also gets into the picture over here. Now, the future of AI involves involving and combining all of these approaches. It could be supervised learning, it could be unsupervised learning, it could be deep learning, and this aim is to provide clinicians with the information, the right cues to make the right decisions for better patient outcomes.